Hi everyone, it's Paul Tilley and welcome back to PR2700 Project Management. Today we're looking at Unit 7, Project Quality Management. Now, as you're probably aware, quality revolves around how good the product is in terms of its fit for use. Does it meet the requirements of the customer and does it hold up over time? So quality is an important thing. Traditionally, quality has been measured at the end point. So we say, for example, we produce a pencil and someone using it will determine whether it's any good or not. Modern conceptions of quality look at quality throughout the production process so that we can ensure that the quality going in is good, so that the quality coming out meets or exceeds the standard. So we're not measuring at the end point when it's all produced, we're measuring throughout. So today what we're going to look at are some of the issues pertaining to quality and some of the tools that are used in order to maintain quality in production and project processes. This is the material covered in Chapter 8 of the textbook and Module 7. So please make sure you take a look at all that and read it after or prior to watching this video. There are two key learning objectives. First, we're going to define project quality management and discuss the importance of how quality management relates to various aspects of information technology projects. And second, we're going to state the purpose of tools and techniques such as Pareto analysis and statistical sampling to show how they can be used in terms of quality control. First, we need to define project quality management. Project quality management is the process of continually measuring the quality of all activities and taking corrective actions at that point in time until the team achieves the desired level of quality. Besides quality itself, quality management processes help control the cost of a project, which is critically important. So project quality management really ensures that the project will satisfy the needs of the end user, the needs of the producer, the needs of the manufacturer. Whatever the needs are of all the stakeholders, they will be met. There's three main project quality management processes really. First of all, there's planning quality. This is upfront before we actually produce anything. It includes identifying which quality standards are relevant to the project and how to satisfy these standards. As we move into the project, we perform quality assurance, which involves periodically evaluating overall project performance to ensure that the project is satisfying the relevant quality standards that we established in the first place. Next, it is really the actual performance of the quality control. It's really the process of reviewing project results to confirm that we've complied with what we said we were going to do. So we've established these defined standards, and we need to make any appropriate changes if there are some deviations found and remove causes of unacceptable quality to ensure that we maintain the standard. Although quality is one of the common constraints of projects, because we need to keep the cost down, for example, and we need to keep the customer happy, it's really an area that doesn't receive enough focus by managers. And, it affects the scope, the budget, the schedule, all of these things. Quality standards really impact it. So people sometimes just assume that since the team wants to produce a high quality project, it's going to happen. That's not the case. So we cannot assume that quality happens by itself. So we really need quality management in place in order to cut off any problems, to reduce any potential negative impacts, and to maximize the chance of success. This graphic here really gives an overall representation of what we've been talking about so far, okay? If you look at the bottom, the project start through to the project finish. And as the project goes along, things need to happen. So at the very top, we need to plan for quality. Quality really needs to be planned up front. And in a quality management plan, we need to establish the measuring. What exactly is the standard and have we met it? So these are known as metrics. We need to check to ensure those metrics are being met, and we need to put a process improvement plan in place so that we have a way to improve any deficiencies that we have. And obviously, it all needs to be documented. As we move through the project in the execution stage, we need to think about the process and the outputs. First of all, the process, as I say, ongoing quality improvement is a standard today in terms of quality management. We need to perform quality assurance. In terms of the potential outputs of particular aspects of the project, organizational processes need to be in place. So we need asset updates, change requests, project management plan updates, and project document updates. These are things that we've looked at so far in the course. These are all related to improving the quality and ensuring that it meets the standards that we've set. As we move through the project further, we look at monitoring control. Right through to the end of the project, we need to think about the process of quality control. And in specific outputs, quality control measurements, we've established those up front. Validated any changes we made. Did they improve? If we made a change, did it improve the outcome? Validating deliverables. Is the material that we've provided up to the standard? Organizational process asset updates. Do we have the right people in the right place at the right time to do the job? Plan updates with regards to the project management and project documentation. So this kind of gives a good summary of how project kind of winds through a project. So let's look at these in a little bit more detail. The first stage, as we looked at, was planning quality. So when we think about quality planning, it really implies the ability to anticipate situations and prepare actions to bring about the desired outcome, right? In quality planning for projects, it's important to describe important factors that directly contribute to meeting the customer's requirements. Again, it's all about the customer. Another important part of quality planning is designing really experiments to test to ensure that we have something that will probably do the job well. This is really a planning technique, and what we really need to do is to think about the goal of the project, and we need to think about, do the item that we're going to put in place, be it computer code, be it the brick and mortar in the walls, does it live up to the standard that we really need? Is it suitable for this particular environment? We think about computer chips, for example, in a computer. We need to look at computer chips and figure out which ones would meet the needs that we have. If we need a computer that lasts for 7 years, do we have a good quality of a chip that will last for 7 years of use? One of the big challenges is information technology projects. If we think about quality planning and designing experiments for items, the problem with information technology, it's also its biggest advantage, is that it keeps changing. And because of this change, it creates a big challenge for quality planning, because the constant change factor makes quality planning very, very difficult. Now, I've already mentioned experiments and how we can use them to determine a level of quality that should be desired in a project, but there are other kind of tools that are used in order to determine quality assurance as well. One is called benchmarking. Now, what benchmarking does is it looks at our product relative to everyone else's. It kind of sets a standard to figure out where we are in terms of quality, usability, all these types of factors, cost. And what we're trying to do is to say our product fits somewhere in that spectrum of products. So for IT projects, benchmarking really concludes such items as comparison of new systems response times to similar applications or similar systems somewhere else. It's really only applicable if there is a competitor that has similar products, okay? So if you have nothing to compare it against, benchmarking won't work. Yet another approach is something called a quality audit, which is a structured review of the quality management activities. So normally, when we think of an audit, it's done by some outside firm or an independent body to look at it and kind of give it a sober second thought. And this means that you're probably going to end up with some different perspectives, different reviews, and hopefully it will allow for an improved approach. As we move through a project, we move into a quality control mode. It's somewhere in the middle towards the end of the project. It is when the project is actually up and running. Everything we looked at so far was really pre-project. So quality control is a process of reviewing project results to confirm that they actually provide us with what we thought they were going to provide us. Is it meeting the standard that we've set? So as we really implement these quality control activities, we need to make decisions on appropriate courses of action depending on the results. Do we need to change it? Do we need to fix it? Do we need to rework it? Is this acceptable? Is it too good? Are we spending too much money on this? So we need to take actions to resolve those problems as we go along. So the most common actions are usually broken into three major types. First of all, there's acceptance. And these are really, if we didn't find any defects, or if the number of defects is within the standard, we're going to say, yeah, that's okay. So if we think about a piece of software, for example, and it does what we expect it to do, that would pass the quality acceptance. The other approach that we have, or the other approaches, deal with things that don't necessarily meet the standard. So for example, rework would come into play if the product that we are producing in the project just does not meet. So in any action, we really need to look at the results and say, look, this is defective. And once it is determined to be defective, then we need to send it back for rework to bring it up to the standard. Process adjustments occurs whenever we have things that are swinging out of control as we move along. So let's say, for example, we have an assembly line that's building product. All the products, or too many of the products come out, need rework. What we need to do is look at the assembly line and say, what are we doing wrong as we build it? And these are process adjustments. We need to take corrective actions really to address quality problems in the production process or in the project process. Now that we understand the importance of quality control and generally how it is approached, we need to look at some of the tools and techniques that are employed in order to make that happen. We have 7 here. There are more, but these are 7 common tools that are used in industry and in programming and in project management that help us ensure that we have quality in terms of the planning aspect and in terms of the production aspect. First, we have cause and effect diagrams, or fishbone diagrams they're called, because it looks like a fishbone. And essentially, it's a really simple process of saying what are some of the potential causes of problems for a product. Okay? So if we look at this here, for example, you'll see that we have the product is the middle line. And let's assume that there's some degree of defect. We got to ask ourselves, what could potentially cause the defect? Well, we analyze a number of things. In this particular example, we have measurement. Is the calibration wrong? Materials. Is the stuff that it's made of wrong? Personnel. Is it a person issue? Environment. Where the product is made. Is it too hot, too cold? The methods. Are we using the right methods to make it? Is there something wrong with the methodology? And the machines. Are the machines working properly that do the production? So this kind of narrows down the assessment to what are some of the potential causes, and this just puts it in a very graphical format that people can think about to assess where problems are coming from. Another type of chart that is used in order to really assess quality as we're going along is something called a control chart. And a control chart is really simple. If you look at it, it has a center line. The black line in the middle is the center. That's the average output, so how many units per hour, these sorts of things. And we have what's called an upper control limit and a lower control limit, the red lines. And that effectively means a deviation. So, if we're making a little above how many we expect to make in an hour, or if we're making a little bit below how many we expect to make in an hour, well, how much is the little bit? How much of a little bit is acceptable? So what the control chart does is it plots the output in a given hour. So as we move along on time is along the bottom there, we'll look at the value or the variation from the average. And as long as the variation from the average is within the control limits, in other words, it's an acceptable level of error or acceptable level of variation, we're good. Once it goes beyond those upper controls or lower controls, in other words, the variation is greater, then we need to stop and assess what's going on with the product. A run chart is a control chart without the upper or lower control limits. Effectively, you look at a run chart and we do exactly the same thing. Time moves along the horizontal and we assess what our standard is, which is the red line, and we're saying, is this above the standard or below the standard? And if it really goes out of whack, meaning it's really below the standard or consistently above the standard, then we need to manage it somehow or another. It's not within control. Another common tool that's used is something called a scatter diagram. The scatter diagram really is a graph that shows an association between a couple of things, height and diameter, for example. So, if something is relative to something else, each individual item can be plotted on this graph. What's his height relative to his diameter? And you're going to create a bunch of dots similar to what you see in here. Those dots should center around a norm or an average, we'll call it. The blue line through it would be your norm or average. Sometimes it's called a regression analysis in statistics. But effectively, if the dots are consistent, we can see a pattern, for example, in this diagram. The dots are pretty consistent. If the dots aren't consistent, meaning that it's all over the place, we don't have some degree of control over the height versus the diameter in this particular example, then we've got a problem. So we look at a scatter diagram and say, how scattered is the scattering? Is it close to the average? If it's close to the average, that's good. If it's far away from the average or consistently different than the average, that's bad. Another tool that's used is histograms, and histograms are pretty straightforward. What we have is, for example, response times in this case versus frequency, and we're just measuring the frequency of a given response time, okay? So it will give us some sort of visual to say, the response times, if we get around 25 per night, let's say, the response times are very good at that point in time. If we get a lot more, the response times aren't so good. See how it gets higher. So it really gives you a relative understanding of what's going on by visually looking at it and saying, yeah, this is working well or not working so well, and we can manage the quality based on that. A flowchart is another common tool that's often used, and effectively it just shows how a process works. And if we think about our work breakdown structure, really our work breakdown structure is a flowchart. It starts at the beginning, flows through the process, showing the things that happen through the process, dependencies and the like, and right to the end of the project. So in terms of project management, this graphical tool is often used to visualize the sequence of steps, to show how the process works, and it allows for a quick and easy reference to where are some of the potential problem points or where are some of the potential issues as the project moves along. Next, we talk about statistical sampling. This is a common one, and once you get your head around it, it's a pretty simple concept. Effectively, it's very difficult to count everyone, or to count everything, or to analyze everything. So what do we do in order to solve the problem of we need to maintain quality, but we can't afford to look at every single item? So what we do is something called statistical sampling. Statistical sampling means we pull out a random sample of the total population of items that we're producing or the total project, and we say that that sample will be big enough to represent the entire population or the entire production. So we pull out randomly a certain number. In this particular instance, for example, let's assume that each one of these dots inside the left circle represents total production. We pull out a sample, a random sample, meaning each dot has an equal chance of being selected. The dots come out. These dots that we can take and measure and do things to, whatever we find from these dots, in other words, we measure them for their roundness or their color or their, some sort of feature. Statistical theory tells us that if it's a representative sample, whatever we find in the sample will also apply to the population. So if 10% of the sample is in error, we can assume 10% of the population is in error. So it's a good, useful tool for determining problems without having to test every single item. The final one that we look at here is a Pareto chart. And a Pareto chart is a very useful tool because it effectively says what are the most important things that cause the most impact. Okay? And if we're looking at late arrivals by reported cause, what are the number one reason, number two reason, and so on. So you can see traffic, childcare, and so on would cause. So effectively, we can say the most important issue to people is traffic, or the most important cause of a problem is identified in the Pareto chart. And it's useful for saying, what could we change that would make the most difference or the most impact? So those were some of the tools, and those tools get employed in a process, a management process called Six Sigma. And Six Sigma, the name comes from the probability curve that we've seen here, the normal curve. And depending on how familiar you are with statistics, basically it says that 99% of all things will fall around an average in a pattern that's similar to indicate it right here, meaning that most things will be close to the average. As we move out, fewer and fewer items move away from the average. Many organizations are using Six Sigma to incorporate all of these statistical techniques that we've talked about here in order to ensure quality. So it's really a holistic process of quality control. So now that we've looked at the tools and techniques, let's go down to the bottom line. The bottom line is that, look, it all comes back to people. All of these tools are useless unless people believe in them and can use them in order to improve quality. So we really need strong leadership to make sure that people are doing what they should be doing. People have to understand the cost of quality, or the cost of poor quality more especially. We need to have a proper workplace atmosphere that enhances quality. People have to truly believe in it. And there's a constant drive to improve quality. So those are people-related issues. So quality is very much a people issue, and the tools and techniques that we've talked about, those are exactly that, tools that those people need to employ in order to make better quality products for customers. I invite you to take a look at discussion number 6, quality management. Please review, and if you have any questions, please let me know. Thanks very much for listening.